and your Zachman, and you've got your modelling languages, and you've done your data models and all the rest of it, what else do you need to be able to do to be good at this job? And I was in a great position to be able to meet a lot of people who were really good at this job, either in conferences or the consulting teams I was working with around the world. One of the things, knocks it out of the park, is the communication skills, the storytelling side. I picked up on that early, and if any of you know about it, I've got a book out there called Stories of the Blue Mountains that is great for architects and how to put together a one-page view of your architecture. Park that, because that's one set of skills. The others I started to look at were what are the things that add to a skill set that start to get you think differently. And I've got Sally Bean sitting in the audience here. Sally and I've talked for years about systems thinking and the techniques from systems thinking. And others that you might see today come around more design thinking and that sort of approach. All add to our skill set. So what I've got here are just a few different things to think about that you might want to put in stuff to learn over the next year or so that will increase your ability to do architecture and perhaps stretch your neurons a little bit further than they have been stretched, and also help some of the people you work with. And if they don't, my apologies. You know, they've worked quite well in the situations I've put them into so far. Constraints, contradictions, and consequences. Three different things, but actually quite related to each other when we're looking at how to understand a problem space and what to do about it. Constraints, first, I'm going to talk through these as three individual parts, but then bring them together at the end. Constraints, first of all. If this green box represents all of the potential solution options we have to a particular problem, day one, it can seem like the world is our oyster. We have the green field to work with. There's all sorts of things we can do. And then reality bites, usually about 2 minutes later, when you start thinking about the reality of the situation. That reality starts with budgets and timelines. How many times have you been told to do a project and the budget is already decided? Come on, let's show of hands. The timeline's already decided as well. So all you can flex is the quality. Yeah? So that's one side that brings the scope in. Procurement policies. Oh no, we can't use that vendor. We've never used them before and you haven't got time to negotiate with them. They're not big enough to work with us. They don't have a government policy approach. Or legislation and compliance. GDPR. How many projects has that cancelled in the last year or so? Certainly from marketing departments who want to be able to share information and use it, and they now feel slightly more constrained than they did in the past. Or existing solutions and the available skills in the organisation. How many of you have got massive data science teams that are working on machine learning right now? How many of you got 1 or 2 people working on it because that's all you could find? Has that constrained the solutions and what you can work with? Or the available skills in the organisation, just simply to keep stuff maintained. We've got architectural solutions, we've only got 2 people left who can maintain that technology stack anymore. That's constraining us, what you can do around it. Principles and debt, your architectural debt. All the stuff you have done in the past, all of those previous projects we like to forget about, that in one way or another have constrained our architectural options for the future. They are constraints. But they're not the constraints I want to get you to now. They're typically the ones we think of. The constraints I want to get you to come from writing by this man, Goldratt. So how many people have ever read The Goal? Good, we've got some hands. If you've been in the manufacturing world, this is almost the Bible to manufacturing. And wherever you want to get into process views of things, and you want to look at a process, this is the sort of work to look at, because here it's about the theory of constraints. And what you see through my slides, loads of links on the bottom. I didn't know whether you'd get them in PDF or anything else, any notes. So follow these and you get quick insights. It's the stuff I use when I'm teaching other people on this, as I think it's the quickest and easiest ways to find out about it. But what Goldratt did was simply look at a problem and find where is the constraint in the process flow. Another recent book written on the same sort of things in the software sense is called the Feebs Project. And it's about a guy who takes over an IT department and has to work out where the problems are. And the problem in his IT department is one guy called Brent, because everything has to go through Brent. And whenever there's a problem in the environment, Brent has to go fix it. So what happens? Every project gets delayed because Brent's not available to work on the project. That is a constraint. So what we look at here are find those constraints and now optimize your process for that constraint. There's no point having high capacity upstream because Brent's going to stop it getting anywhere. There's no point having high capacity downstream because it's only as much as Brent can produce. Well, where does that fit in our architecture? Just how many messages can your MQ series or BizTalk system put through? How many API calls can you handle a minute through your Apogee gateway? Those are the sort of things that produce constraints in our environments. Some of them are easily scalable as long as you design the architecture the right way. Some of them not. But what I suggest to you and want to look at here is examine your architectural floor plan to find where your constraints are. What are those current rate limiting factors in your organisation? And have you optimised your architecture to them? Because you can adjust your investment portfolio. If that constraint can't increase, there's no point putting more work through to it. It can totally constrain your ability to change. I've used this with business capability modelling. So you do the capability model for the organisation and then heat map that, asking questions that help you understand. Is it at capacity for throughput? Understand that and then find the business processes that that capability is used for. And now you start to find where the constraints in your organisation are surfacing. So it's not always about the technical detail and individual units and machinery. Actually take it right up. Use this at a business architectural level as a theory of constraints to understand your processes. And when you found that constraint, you subordinate everything to it. That is the limiting factor. Until you say we've got to increase the constraints. You go and hire another Brent, so you've got two of them, or you redesign or refactor your architecture to take that unit out completely, and your constraint will go somewhere else. You are never constraint less. You haven't got that much money. But you are in a position to understand which constraints you're prepared to live with. Next one then, contradictions. I'll indicate of keep left with a right hand arrow. How many contradictions do you think you have in your organisation per minute? Now I need to integrate data from all across the company for the BI dashboards. These are real contradictions, not hypothetical ones, very real I've come across in just the last 6 months. But at the same time, oh no, we can't give access to data to people, they've got to have explicit permission for it now. You can only see the data that's allowed to be given to you for the purpose of your role in the organisation. And there has to be a data owner that can grant it. So you've now put a massive constraint around your ability to satisfy the problem here. And those two put together, if there are two requirements for the same project, will drive you around the bend trying to satisfy them. Usually they'll come from two different stakeholders, but you've got to get that contradiction resolved, first of all, because that's a contradiction in the requirements, unless you can find some way to solve it. Here's another one. It's just a, sorry, go back. It's just a proof of concept, so we should build it simply. That way we can get it out the door. Through to, we're going to scale it fast because it's worked. And both of those you get at the start of the project as well. Come on, show of hands again, who's had that one? Let's build it fast, then scale it. Yeah. So if we see that contradiction all the time, do you have a pattern that you can use to be able to solve it? Do you even identify it as a contradiction? So a suggestion I would have to hear, just as you have a risk index and issues and things like that, your RAID log, where's your contradictions when you identify your requirements? Do you actually have a list of contradictions that are impossible to solve for or that will need further work? We don't have that formally in our organisation, but it's informal. I'm asking it all the time when we're looking at the solutions. Where's the contradictions? Because the next stage is a conversation to either remove one of the contradictions from the mix or then to start working out, so what options do we have to focus on this? And here again, I'm going to take you back to some work that was done many years ago. Who's heard of trees? Again, it's the same few hands there. There are some educated members amongst you who have already been out and searched the world for other tools. So, you know where they're going from. Going straight down the middle line almost here to ask for more information on these later. But trees is a Russian term. So, theory of inventive problem solving. So the TRIZ, so trees. This comes from work analysing patterns on physical designs and being able to resolve the contradictions in trying to change a physical design. And that when you look at the different sorts of contradictions you have there, there are many different patterns that can solve that contradiction that have been done time and time again. There's a whole lot of work that has been done identifying the software contradictions as well, and the work behind that. There's a lot more software contradictions were identified than anything to do with the original trees work. Perhaps that's just a case of software people like to make it more complicated than anybody else. But here we have the 39 contradictions that came from the original work mapped to 40 different inventive principles, so ways in which you can solve the problem. So if I have two different contradictions, number 12 and number 36 from a list. So number 12 is about shape. I want to change the shape of my device. One of these things. Okay? I want to make it smaller and lighter. No, actually it's just smaller. Smaller is the shape, lighter is a different one of the contradiction features. Device complexity. It's going to do a lot more than it currently does. How do I fit that in? Well, I'm going to wait until the silicon gets a lot smarter and the battery's going to look better, but I can't wait that long. So I'm going to do something else with it. If I look up number 12 and 36 in a matrix which is provided with trees, I am advised that there are these 4 different inventive principles I could use with descriptions behind them of how to apply it. Segmentation. Why don't we just have the screen separate to the back end? You know that phone that we used to have that didn't have a screen on it? So it's got a battery, a receiver, and instead just got Bluetooth. And then anything else I might have around my person, and a personal area network is connected to it. Anybody got an Apple Watch? You've already got part of this implementation. The functionality has been moved to your wrist instead, and it's connected. When you get the earbuds in, it's the same sort of thing. So that's starting to take that approach of segmentation, split my device so I can down on one shape and put functionality elsewhere. And there's many other patterns you can use to have descriptions behind them. So straight out, I'm not having to sit there and think, oh, shall we do a brainstorming exercise, what to do? I look it upon the grid and I go, these 4, can we do any of them? And behind the scenes, that segmentation, there's all sorts of things I can do. I want to make my phone smarter. Well, I could have just enough processing power in the phone and stream the rest of it to the cloud. If I'm going to be sitting there with a high-speed network, why put all the processing power in the phone? That's exactly what Amazon and everybody else is doing these days with the voice recognition. Your phone doesn't sit there and analyse the voice stream. It's being segmented for you and sent off. And Alexa is processing it in milliseconds as it's getting slices of your data. It's processing, adding it up, and then sending the response back to you. We've just changed where the CPU is in that part of the process. So in terms of contradictions here, my advice to you is find your contradictions. Deliberately look for them in your architecture. Take the principle from this, and then say, what patterns can we use in our organization to be able to break those contradictions in future and deal with them? The last one, consequences. What are the consequences of your designs? It's great as architects. We can abstract reality. We can get rid of all those messy details and put a few boxes and lines on the page and go, it's going to be something like that. You know, we'll conceptualize it like this, we'll draw the models out, but there are consequences. Every time we redraw the world, every time we engage reality or try to park those clumsy little details into a box somewhere, there are consequences for making those choices. You can't avoid that reality. One way of looking at those consequences that I picked up early in my career and came back to a couple of years ago, failure mode and effect analysis. Anybody come across this? Do I have the same hands? Oh no, there's a couple missing here. Engineering. Systems thinking and engineering, this comes from. A good few years ago now, I taught the systems thinking course for the OU, and this was one of the core modules within it. But go through, what are your components? What is the cause of a failure? What will be the effect of that failure? What's your mitigation? So all you can do is take your architectural diagram and see if you can break it. Let me take that one step further. Do this in a closed room. Do not have business people in the room with you. It scares the hell out of them. Get your team together, your security architect, your infrastructure architect, your apps people, and now deliberately try to break your organization. Go and wreck it, a wreck it workshop. Think of everything you could do that could bring the organization down, that could destroy that application, whether internal or external, and then start to determine whether you've got the means that address that. in what you have sitting in there. I say do it in a quiet room, and then when you've learned what you need to know, go and fix it before other people find out. But this failure modes effect analysis approach is core to structuring that sort of thinking and giving you a far more resilient architecture. In the Enterprise Architecture Conference later this year in October, the IRM one in London, at least 3 of the sessions will be about security and the architecture you need to think about to make your enterprise more secure. And this is one way to really look at that. Are you building fragile architectures with agile techniques? Or are you going to start building things that both scale and stay together no matter the circumstances? And here's another one I've come across recently. This is only in the last couple of years, working with our manufacturing unit. And this stuff goes all back to the original Kaizen thinking, so 1960s it was written about. Poka-yoke is about designing systems that don't break. Here's the simplest example for you. We have machines that collate papers. So I work in the department at the Cambridge University that does exam processing. So we get 8 million scripts back every summer from students that have marked all over them for their A-levels and GCSEs. And we need to run those scripts through machines. And they can come back at different sizes. So you have to fine-tune a little screw on the side to be able to get the paper to go through the scanners. How many times was that screw not finely tuned enough and something jams along the way? Too many. The internal Kaizen team looked at this, one guy went away and thought about it, he came back with a little metal jig. It's only got 2 points on it for the 2 different sizes of paper that actually come through, but they're always trying to tune between one and the other. So he puts the jig on the surface and he screws the thing down to it and lifts the jig out. Job done. Can't go wrong. Now put that thinking into the software sort of world, and 20, 30 years ago it was make sure your data can only be entered correctly. Don't allow free-form text fields to just put stuff up. Make sure your data validation is done at the point of capture, not at some point later where it crashed the system. Somewhere along the way, some of that's got lost with these modern web systems. I've certainly noticed how many times I can use an online system and I'm able to insert text into it and then crashes it later. Or it's been too finely tuned and I can't put my home address in. Because as soon as I put the first couple of lines and I want to tell it, no, it's I live in a barn and that's got to be the first bit, otherwise it goes to number 2 down the road, not number 2 East Barn. I can't put it in there because they've over-tightly subscribed the field and it now doesn't work. It fails. So here, this is about mistake-proofing your solutions. Learn the technique. There's far more in Kaizen to learn from. This is something to think about. We're enterprise architects. We're thinking big picture, big processes. I'm getting a fantastic amount of value from Kaizen techniques, the tiny iterative improvements. Because once you've worked out that big picture, use these techniques on it. In fact, drill a little further and look at the 8 different types of waste that come from the Kaizen approach. How much of that waste do you have in your solution? Do you have information being moved around that doesn't need to move around? That's a waste. So you want to look at these and start thinking, that's how we iterate from a good enough solution to a great solution. And that's where all 3 of these different thoughts that I'm trying to give you today come from. I'm guessing you're already pretty good architects. Most of the people in the room. I know there's a couple just starting and here to learn what it's going to take to get there. But how do you go from good to great? How do you go from, I've learned my TOGAF, my ZACMA and all the rest of it, but I'm still having trouble. Every day I get up and there's still things that are bugging me, still stuff that's not right in the organisation. To get better, what you need to do sometimes is get a few better tools in the toolbox. And if you missed the session earlier that Tom did, he's got at least 50 apparently in his toolbox. You'll take a look at. I'd recommend you take a look at his video recording later. But increasing that tool set that we have is one of the best things we can then do to be able to work with teams. But there's a caveat. A caveat that causes all of this to fail. You might be doing constraints, contradictions, or consequences. What do you want to work with there? If the people you're working with don't know the technique, you've got a serious problem. Because you're now going to have to work at the speed of the slowest person in the room who's interested, who doesn't know the technique. And this is where a lot of brainstorming and innovation work falls apart, because if you're trying to work together as a group, but you all have different techniques, you can't. you will all work in slightly different ways. So you actually need to learn how to use the tool or the technique first, and then you've got the common language and the common approach. So if you're going to use the contradictions approach, everybody in the room, first of all, has to go through a little exercise to understand what a contradiction is, how to look at a contradiction, and then how to work out what sort of principles might help you resolve it. If you haven't got that, two people will be off sorting it all out, and everybody else will be sat there. Should I check my emails? What do I do? Yeah, looks like Tom's got it. I'll leave it to Tom. And all you're left with is Tom's best idea, which may be fantastic, but nobody else knows. When everybody else knows the technique, then they can work well with Tom. Tom can be challenged on it, and Tom's ideas get better, as well as everybody else being able to contribute to it. So that's the caveat I give you here. Don't just dive in and do it yourself. Learn it, but make sure the teams you're working with have learned the technique, and then you'll really get the acceleration from it. That's it. I tried to keep it short and sweet. And I'll have to take questions if I've got time for them.
You have it. I really enjoyed that. A very simple set of C's, I suppose. Were there any others you looked at? One that particularly interests me is coincidences. But were there any other C's that you considered before you chose those three?
No, the fact they were all C's was just chance. I've got 3 A's, I've got a couple of B's, and I'm starting to think about, do I actually have an alphabet of architectural tools? But I'm having real trouble with X, and U's not so useful. But no, at this point, I've got lots of other tools that come into the mix. These are the 3 that have had most of an impact, well, 4 actually, the 2 that I brought up with the consequences, that have had most impact in the last 12 months. So, to a certain extent, actually top of mind, but saying, yeah, these are the ones that make a difference. Any other questions or thoughts? Then I recommend you to go and follow some URLs, read some pages, watch some videos, and go and give them a try. Thank you.
Thank you.